Concentration is a super important concept in science. It's our way of expressing how much of one thing we have with respect to the amount of another. There's all kinds of concentration units, both technical and non-technical. We could talk about the concentration of sugar in my glass of sweet tea. I like it pretty sweet, so maybe we could say the concentration is 2 cups of sugar per gallon of sweet tea. Whereas when my husband makes it, he doesn't like it so sweet, so maybe his concentration is half a cup per gallon. So a cup per gallon or a half a cup per gallon, those are pretty unwieldy types of concentrations. So when we are in the scientific realm, we want to have a more specific and technical definition or a way to express our concentration. In chemistry, by far the most popular way of doing this is molarity. Molarity, denoted big M, is defined as moles of solute per liter of solution. Now, in order for this definition to make sense, we need to define both solute and solution. And what we're going to see is that to define solution, we actually need a third term, which is solvent. We'll start with the idea that a solution is equal to solute plus solvent. The solute is the thing that undergoes dissolution, and the solvent is the thing that does the dissolving. If we had a cup of salt water, for example, sodium chloride or salt would be the solute, the thing that undergoes dissolution, and water would be the solvent. Note that when we look at molarity, again, we're looking at volume of solution, not volume of solvent. That's a common misconception. The reason for this is that volumes aren't strictly additive when we make a solution. Let's run through a quick calculation where we find the molarity of a solution that's made by dissolving 10 grams of aluminum nitrate in enough water to make 250 milliliters of solution. I've gone ahead and provided for you the molar mass of the of the aluminum nitrate, and probably this is a good hint to you that you should not rely on an exam, that you need to use the molar mass to convert the grams of aluminum nitrate to moles. So let's start there. We start with the 10 grams of aluminum nitrate, and we use the molar mass such that the grams will cancel, leaving us with moles of aluminum nitrate. We get 0.04695. Now we need to divide that through by the volume, but remember the volume must be in liters, so we need to convert our 250 milliliters into liters. So our 0.04695 moles of solute divided by 0.2500 liters, which is just the 250 milliliters converted to liters, gives us a concentration of 0.188 molar.